Hello everyone, myself Monica Heste. We are discussing about the subject system software and compiler design. So in this, what are the agenda in this PPT? What are we going to study? So the first thing is what is actually meant by backtracking. What is backtracking, and how does it works on compiler design? And some of the examples and what are the advantages and disadvantages. To start with, what is backtracking? The parse tree is started from the root node, and input string is matched against the production root for placing them. For example, to understand this, I'll be telling or giving you a simple example where for this is the root node is the his, and CAD is the production. We and again the other production is the A B slash A. By using this productions, we have to match the input string such as C A D. This is the output. By using this two productions, two terminals, we have to produce the input string. Uh, in the first point, the parse tree started from the root node, and the input string is matched against the production rule for replacing them. So if we replace them, we'll get the uh, input string. Handle back tracking it also handles the situation where the past continues encounters ambiguity and uncertainty in the input grammar. It involves temporary moving. So if the production if the terminal is not matching, we can temporarily uh, move back to the other terminal or the other grammar. Previous discussion, the decision point in the passing process, trying to alternate the option. We are trying to alternate the option to match the input string. Moving on, there are some general overview of how backtracking works, how it actually works in compiler design. The the passes starts with a specific grammar rule and corresponding input tokens. Input tokens are the input strings which we have to achieve that. It attempts to apply the rule and matching the input tokens. Obviously, the input strings are to be matched by using the production rule. There may be several production rule. We have to go in series. First, we have to take the first production and next the second production. If for example, if we have or there are for example, if we have one production, second production, third production, fourth production, we have to go in series. The first with first production, and next is grammar produces the second production, and next the third production, and next the fourth production. So like this, so on. For matching is successful, the pass produced to the next rule or the token. If the string is successful, next we are moving on to the next production. If the rule or token doesn't match, if the if this doesn't match, we have to move back to the uh, you know in the previous example, as I told you. So if A C A D, and which gives A B, sorry, I'll be telling you in a different one. Okay. If none of the alternative work, the parts backtrack the further to explore other possibility. The process repeats until a Valid parse tree of ASI is constructed and possibilities are exhausted. So we have discussed how this backtracking works. Now with the help of example, will be will be clearly understanding how it works. All right. So first example, let me take the pen. Yeah. So example 1, for example, S gives C A D and A gives A B and A. We have to produce the input string such as CAD, right? Now first we'll take S production. S is the root node. For this, productions are only one production is there. Here in A there are two productions, CAD. And next we can replace this A. Now we'll see the output string. Output string is CAD. C here it is small terminal. Here it is the capital letter. So here the capital letter is the A and B. This is production number 1 and this is production 2. Now 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 here it is C, A, B, D are there. Alright. C, A, B, D. So this is not the right one. Now we'll see the next one, next production with this A. So S, C, A and D and A which gives A. So here comes CA, CAT. So our output production is produced C, A and D. This is the um, how backtracking works. Now if this doesn't work, we have to backtrack. Wait one second, let me change the color. Yeah. So here it is producing C, C, A, D, A, B, D, right? Now it is not the output string which we are expecting. So what we have to do, C, now we have to backtrack to the A again so that the next production is used. So this is how the backtracking works. We'll also look at one more example so that it will be clearly understood. Okay. So one, S gives C, A, B. One second, I'll just write it neatly. S gives C, A, B, D and B, A, C and A gives B, C, D and A, B. B gives A, C, D, A and B, D. Now the input string which we are expecting is B, D, A, C. With the help of this, we have to produce this one. So how we are going to do? Now first let us consider S. So S gives C, A, B, D. This is first production. One second. This is first one. Now S gives second production. So that is S gives B A C. Right. Then now we have to replace this A. We have the A productions, right? So we can C D. So our expected output is BDAC. Here we are not getting C A BDAC. So what will now check out the second one. So we have to backtracking is done. This is backtracking so that it moves to the next production. Now back out. Now the second production is written. Here we have, right, this is second one, AAB. So now let us write AAB. AAB. By using the second production also we are not getting the output, so we'll try on to the next set of production. Okay, we can replace this B by A C. So here also we are not getting the expected output, so let us rub and next move on to the next one, second production. In B there are three productions, B A. So here also we are not getting, so let us move back. Backtracking is done. As backtracking, now let's see the third production, whether it is suitable for the output or not. So it is B D. So here comes the output what we are expecting, it is BDAC. So this is how the backtracking is done. If you're not getting the expected output, we have to backtrack and move back to the position, and we have to see replace it with the next production. And then what are the advantages? Moving on, let us see what are the advantages of backtracking. Handling ambiguity. Backtracking is particularly, it is very useful grammar in the language. Being passed in ambiguous, it allows the past to explore multiple alternatives. So we saw multiple alternative and resolves the ambiguity and finding the correct implementation to find out the correct implementation. And next is flexibility. It makes the tentative decision. It makes the correct decision and explore different paths. So we are explored the by exploring different paths we can find out the output. It construct the techniques, but maybe it is insufficient. Easy implementation, it is very easy to implement, and it is very easy to understand as well. And what lastly to discuss about is the disadvantages of backtracking. Disadvantages are performance overhead. It takes more um, time to see the result, and ineffective parsing algorithm. It is very expensive and involves multiple paths, so we are consuming multiple. I mean, we are going through multiple paths, right? And then lack of predictability. You know, it is less predictable since the paths explores different path. It tries multiple alternative, not be immediately clear with path and leads to successful path. And limitation on overhead, limitations on look overhead to decide. It requires look overhead to become too large and leads to insufficient. It is becoming too large. Yeah, the steps are repeating, so the space is occupying. Difficulty in error recovery. If there is error in the algorithm, it is very difficult to recover and it is more challenging, and it takes the multiple paths and alternative options, right? So this process can be complex and might not be always result in most useful error message for the developer. To summarize, backtracking is useful technique for handling ambiguity in a design, a compiler design. The drawback in term performance, predictability, error recovery, and minimize backtracking by using more effective parse algorithm. We can use other algorithm to use it more effectively, minimize the backtracking and find out the result very quickly. uh, Techniques by memorization or look over it to improve the overall passing performance and reliability. So this is all about today's PPT. Thank you so much.